All right, so we're going to practice communicating enthalpy here. All right, so what I'm going to do is we're going to do an example of each one, and then I would like you to try to figure out how to do this. So I'm going to do the example. Then you should pause the video, try these two on your own. Then once you got one tried, you can watch the video and see how it's done. Right? It's important to try on your own. Practice communicating enthalpy. For each of the following chemical reactions, balance it. Then rewrite it in delta H notation for 1 mole of the underlying substance, molar enthalpy form. Okay, so first thing you always do is you balance the chemical reaction. So let's look at this one. We got Fe2O3 solid plus carbon monoxide gives us carbon dioxide plus iron solid. We've got plus 25 on the products. So I'm just going to make a note that this is an exothermic reaction. We know that already. Exothermic means our delta H is going to be negative. So first thing, let's balance it. We got two Fe's. We need two Fe's over here. We've got one C. We've got one C over here. C's are balanced. We've got four O's. We've only got two O's over here, so we need to double this guy up. Now if we double this guy up, this guy's got to get doubled up. And then we're unbalanced again. So let's take a look again. Now we got 5 O's. And we've got 4 O's here. Well, let's try moving this guy up to 3. And moving this guy up to 3. See what happens. Our Fe's are still balanced. Now we've got 3 C's, we've got 3 C's. We've got 3 O's, that's 6 O's, we've got 6 O's. This is balanced. 1, 3, 3, 2, F. Now, we want to write this so it is in delta H notation, so it's got delta H separate, for 1 mole of this guy. Right now, this guy, carbon monoxide, has 3 moles on him. So first thing we're going to do is we're going to go to delta H notation first. So we write this as 1 Fe2O3 plus 3CO yields 3CO2 plus 2Fe, and our delta H is equal to negative 25 kilojoules. It's the first step. That's delta H notation. Sorry, that's not the first step. That's second step. So we balanced it, and we changed it to delta H notation. Now what we want to do is we want to make it so that it has 1 mole of CO. Well, these are all just ratios. It's all just a ratio. So to get this to 1 CO, we have to divide everything by 3. Divide every number by 3. And we will get 1/3 Fe2O3 plus 1 mole of CO. That's what we're looking for, the 1 mole of CO. This will give us 1 mole of CO2 plus 2/3 Fe. And delta H will be equal to negative 25 divided by 3, which is negative 8.3 kilojoules. So what this means, if we react 1 mole of carbon monoxide in this, we're going to get negative 8.3 kilojoules of energy out. So step 1, balance. Step 2, take the energy out. Step 3, make it so that it's 1 mole of the underlying substance. All right, so right now you should pause the video, try questions 1 and 2 on your own. I'm going to go through question 1 and 2 so you can check. So pause and do the work now. All right, hopefully you're doing this after you've tried it. So question number 1, first step, balance everything. 1N, 1N, 3 H's, 2 H's. So I'm probably going to need to get this guy up to 3 and this guy to 2. Then I'll need this guy at 2 to balance my N's. Now I've got 2 N's, 2 N's, 6 H's, 6 H's. Now I've got 5 O's on this side. I can't get this to 5 O's. I can do 2.5. That gets me to 5 O's. So I just have to double everything. 4, 5, 4, 6. That should work. 4, 5, 4, 6. 4 N's, 4 N's, 12 H's, 12 H's, 10 O's, 10 O's, balanced out. So step 1, balance. Step 2, rewrite in delta H notation. 4NH plus 5O2 4NO plus 6H2O, and our delta H, because this is an exothermic reaction, is negative 1170 kilojoules. So step 1, balance. Step 2, rewrite in delta H notation. Step 3, go for 1 mole of the underlying substance right here. So we got to divide everything by 4. And I'm going to need a calculator for this. I don't know where my calculator went to. It's way over here being charged. Okay, so we will get, as an answer, we will get 1 mole of NH3 plus 5/4 of a mole of O2. You can leave that as a fraction. 1 mole of NO plus 6/4 of a mole of H2O. And our delta H will now equal 1170 divided by 4 equals 292.5, and that's negative. All right, so let's do number 2. Hopefully you've tried it on your own. First step is to balance. 1 H, 2 H's. So we need 2 of these guys. 1, 1. That's balanced. First step, balance the chemical reaction. Second step, write in delta H notation. 2 HCl plus, no, we don't want the 96, we don't want the energy in the reaction anymore. 1 H2 plus 1 Cl2, and our delta H, notice our energy is on the reactant side. That means it's absorbing energy from the environment. It is going to be a positive because it's endothermic, plus 96 kilojoules. Now we rewrite it in 1 mole of our underlying substance, so we have to divide everything by 2. And we get 1 HCl gives us 1/2 of a mole of H2 plus 1/2 of a mole of Cl2. And our delta H will be equal to 48 kilojoules in the positive sense. We can just read these numbers as moles. Okay, so that's the first section.